Everyone, in this question, it involves polynomials and inequalities. So part A states that on the axes, sketch the graph of y equals 5, x plus 1 times 3x minus 2 times x minus 2, stating the intercepts of the coordinate axes. In part B, hence find the values of x for which our expression is greater than 0. To find our x-intercepts, let's write down our equation equal to 0. So that would be 5 x plus 1, 3x minus 2, x minus 2 equals 0. So when we solve this equation, x will be equal to -1 from this factor, 2/3 from this factor, and 2 from this factor. These will be the x-intercepts on the graph. So let's mark them as 1, 2. So this is 1, this is 2, this is -1, this is -2. So we'll mark on 2 here. And we have 2/3, so that's about here. And we have -1 here. So the next step is to find the y-intercept. To do that, we'll just let x equal 0. The y will equal 5 times 1 times -2 times -2. So y equals 20. So this will be your y-intercept, which is the coordinate 0, 20. So the x and y scale are different, so let's just mark 20 here somewhere. If you were fully to expand your function, your leading term would be 5 times x times 3x times x, which is 15x cubed. The important point here is that this value, 15, is positive. So the general shape of our polynomial will look like this. That occurs when we have positive values for x cubed. If you had a leading term which was, say, -x cubed, your graph goes in the other direction. So this refers to the end behavior of the graph. So using that idea, our graph will look something like this. So let's go down through our first x-intercept, we turn, go through the other x-intercept, we'll go up, go through our y-intercept, turn again, and go through our last x-intercept. So your graph looks something like this. This is a graph of y equals fx, let's call it that. So to do part B, we can actually use the graph easily to solve this. We want to see where your function is greater than 0. That is positive. Your function will be positive when above the x-axis. It will equal 0 on the x-axis. And it would be less than 0 or negative when it's below the x-axis. So when you look at your graph, you have to ask yourself, where is the graph above the x-axis, greater than 0? So we see that here, and we see that here. And notice from our question, we must be greater than 0, which means we cannot include the x-intercepts in the solution. Observe the area shaded in green. We can see that one of the solutions will be x greater than 2. And the other solution is between -1 and 2/3. So these are the only parts of the graph where your polynomial is positive. Thanks for watching.